You know when you see a really stunning piece of 3D art and you just stop and wonder, how on earth did they make that look so real? Well, a huge part of that magic, maybe the biggest part, is in the materials. Creating those complex, pro-level textures, that is the skill that can take your work from pretty good to absolutely amazing.
And yeah, for the longest time, it's felt like all the best tools were locked away in these expensive, super specialized programs. You see what people can do with just a few clicks in those apps, and it's easy to get a serious case of, texture envy. But here's the thing. What if I told you that all of those incredible dynamic results with all the fancy tricks like curvature maps and procedural edgeware, what if all of that was already possible right inside of Blender for free? Well, it is. And that's exactly what we're going to break down right now.
All right, let's get into it. Here's our game plan. First, we'll set our goal. Then we'll dive into crafting the procedural stencils that make this all work. After that, we'll layer in all the realistic details, and we'll finish up with a huge payoff, creating a genuinely smart material.
Okay, so every masterpiece starts somewhere, right? We're not just jumping into the deep end. We're going to start with a simple 3D model that has a really basic two-tone material. Think of it as our blank canvas.
The initial setup is actually super straightforward. We just use a mix RGB node to handle our two main colors. In this case, a kind of yellow-orange and a blue-gray. The real key here, though, is using a gradient texture as a mask. That's what gives us that nice, clean split between the top and bottom of the object. And now we get to the secret sauce. This is where the magic happens. We're going to create a series of black and white procedural masks. You should really think of these as smart stencils. They're what will tell Blender exactly where to put all the good stuff. The wear, the dirt, the highlights. So, our very first mask is called a curvature map. Its whole job is to scan our model and find all the sharp, exposed edges, the parts that would get scuffed up in the real world, and also find all the deep crevices where grime and dirt would naturally collect. This is really the foundation for all the realism we're about to add. So how do we build it? We start with a geometry node, which has this amazing output called pointiness. It's basically Blender's built-in way of finding those sharp bits and deep cavities. We feed that into a color ramp to really punch up the contrast, making it black and white. A gamma node helps us fine-tune it. But, and this is the crucial part, we multiply the whole thing with a noise texture. That breaks up the perfect, clean digital lines and gives it that organic, chaotic look of real life. Next up is the edge mask. Now, you might be thinking, wait, didn't we just do edges? And yeah, we did, but this one is different. It is laser-focused on finding only the outermost edges of the object. This is absolutely perfect for creating that classic chipped paint effect, where an object's been knocked around a bit.
Now, this one's a little more technical, but it is so incredibly powerful. What we're doing is asking Blender to compare two things: the direction each face on our model is pointing, that's called its normal, and the direction of a virtual beveled edge. A vector math node set to dot product finds the difference between them, which brilliantly reveals only the sharpest edges. And just like before, we'll use a noise texture to break it all up and make that wear and tear look natural and random, not perfectly straight. And our final mask is ambient occlusion, or just AO for short. Put simply, this just calculates all the nooks, crannies, and corners that are kind of shielded from the main light source. And in the real world, where do things get dirty? Exactly in those spots. It's perfect for simulating accumulated dust and grime. And the best part is, Blender makes this ridiculously easy. There's literally a dedicated ambient occlusion node. We just drop it in, feed a little bit of noise into it to make the dirt look more varied and clumpy, and then, you guessed it, use a color ramp to dial in exactly how much dirt we want and how dark it should be. All right, we've done the hard part. We've built our 3 intelligent stencils: the curvature map for general wear, the edge mask for chipped paint, and the ambient occlusion mask for grime. Now comes the really fun part, actually putting them to work and layering on all that juicy, realistic detail. So first up, we're going to add some subtle color variation. We use our ambient occlusion mask to mix in a darker brownish color right into those crevices, making it look like dirt has built up. Then, we use our curvature map to add a slightly lighter color to the sharpest edges, which gives us some nice, subtle wear and highlights. Now we bring in that powerful edge mask. We use it as the mixing factor for another node, but this time we're mixing our main paint color with a dark gray bare metal color. And because of the mask, that metal color only shows up on those worn down edges. It's so satisfying to see. And here is where it gets super efficient. We can take that exact same edge mask we just used and plug it directly into the metallic input on our main shader. Boom! Instantly, only the parts where the paint has chipped away will actually look and reflect light like real metal. It's that simple.
Now, creating a good roughness map, the thing that controls how shiny or dull a surface is all about logic. Think about it. The bare metal edges should be pretty reflective and shiny, right? But the accumulated dirt from our AO mask should be super dull and rough. By combining these masks, we build a complex new map that gives every single part of the surface the correct physical property. For the final touch, the thing that really sells it, we're not just going to fake the dirt with color. We take our AO dirt mask and we plug it into a bump node. This gives that grime a subtle physical depth, making it look like it's actually caked onto the surface of our model. So we did it. We've built this beautiful, complex, realistic material. But the true power of doing things this way procedurally goes way beyond just this one static texture. And this is the real game changer. Because we built this material using a set of rules and logic instead of just painting details by hand, what we've actually created is a smart material, an adaptive material. So what does smart actually mean? It means that if you change the 3D model, if you stretch it or add a new piece or change its shape completely, the material automatically updates itself. The edge wear finds the new edges. The dirt settles into the new crevices. It all happens instantly. What you've made isn't just a texture, it's a reusable tool that you can drop onto other models. That is the incredible power of proceduralism. By understanding these core techniques, building masks for curvature, for edges, for occlusion, you've basically just unlocked the ability to create nearly any complex material you can possibly imagine. And you can do it all right inside of Blender. So really, the only question left is, what are you going to build first?